Question 6 is a curve sketching question, which is built up over a number of different parts. And the first part is simply to solve this equation here. Now, if we were to multiply it out, we'd get a cubic equation, and what we'd do is we'd factorize it. So this is already factorized for us to a certain extent. And what we say then is if you have x upon x minus 27, sorry, x squared minus 27 equals 0, then either x equals 0 or x squared minus 27 equals 0. In other words, x squared is equal to 27 and x is equal to, and be careful here, it's plus or minus the square root of 27. Now root 27, we should be able to simplify that a wee bit further, because root 27 is root 9 times root 3, which is 3 root 3. So our answer here is plus or minus 3 root 3. So first part, x equals 0 or x equals plus or minus 3 root 3. Second part, now you notice this bit here, y equals x cubed minus 27x is exactly the same as this part, except that it's been multiplied out. And so this is very, very closely linked to what we've done before, and we will use it then in the oncoming parts. So if y is equal to x cubed minus 27x, when we differentiate, we get dy by dx. We differentiate y with respect to x. And to differentiate each term, we multiply through by the power to get 3x, and we reduce the power by 1, 3x squared. When we do that to minus 27x, we get minus 27. When you differentiate an x term, you just get the constant or the number in front of it. So there we go, dy by dx is 3x squared minus 27. So part 3, find the coordinates of the turning points on that curve. Well, we've already seen that dy by dx is equal to 3x squared minus 27x, minus 27, sorry. And that's very, very important, because when we want to find turning points or stationary points, we know that the gradient is 0 at those points. In other words, dy by dx equals 0. So 3x squared minus 27 equals 0. 3x squared is 27. X squared is 9. And again, be careful, x equals plus or minus 9. And so we have two values for x. But look at the question. It says find the coordinates of the turning point. So we need to be slightly careful. All that we've found here is the x coordinates. And in fact, you'll notice here, it's plus or minus 3, isn't it? If, or at x equals 3, y is equal to, well, 3 cubed is 27, minus 3 times 27, which is 81, and y equals negative 54. So we have the point 3, negative 54. At x equals minus 3, let's look at the equation. Y is equal to minus 3 cubed, which is minus 27. Minus 27 times minus 3 is plus 81, which is 54. And so we have the coordinate minus 3, 54. Now, from these 2 points, you'll be able to even guess, if you were to plot those on a graph, which is the maximum, which is the minimum. However, part 4 asks us to determine the nature of these, and we don't do that graphically, we do that using differentiation again. And to do that, we take the dy by dx and we differentiate it again. D squared y by dx squared. So 3x squared differentiates to give 6x, and 27 differentiates to give 0. At x equals 3 then, what is the second differential? D squared y by dx squared is equal to 18, which is a positive value. If you think of a positive value being a happy face, that's a minimum point. So we have a minimum point at 3 minus 54. And that makes sense because minus 54 would be the bottom value there, the minimum point. I would expect at x equal negative 3, then d squared y by dx squared to be a maximum point. But let's show it. 6 times negative 3 is negative 18. That's a negative value, funny enough. Negative, if you're in a negative frame of mind, you're unhappy. So there's your sad face. But that is a maximum turning point at negative 354. Now the last bit of this says to sketch the curve. We have all the relevant bits of information in these previous parts. We have where the curve crosses the x-axis. We have the turning points, and we should be able to sketch this on a graph. So let's do that now. Here's our curve. We should put our axes on it. This is our y-axis and our x-axis. Where does it cross? Well, it crosses at 0. I know I've a maximum and a minimum point at minus 3 and 3. And it also crosses at 3 root 3 and plus or minus 3 root 3, which is roughly about just after plus or minus 5. But I'm just going to put minus 3 root 3 there. And over here, 3 root 3. Okay. In terms of our vertical scale, it crosses the axis at minus 3 root 3 at 0 and at 3 root 3. At negative 3, we had a maximum point, and this is up at 54. So let's put that in, negative 3, 54. And at 3, we had the corresponding minimum point, so that's 3, negative 54. And it's now a matter of joining all those points together. Notice this is a cubic, it's a positive cubic, so I'd expect it to go something like that. And if you look at the points that we've plotted, then it will fit into that kind of shape. So let's just put it in. There's our maximum point. It's coming through 0, down to our minimum point, and up again. Last thing, let's put the equation of the curve. Y equals x cubed minus 27x. And there's our curve sketched. A couple things, just notice as you come in and out of the maximum minimum points, let's not have that too V-shaped. Okay, it is a curve, it should be curved and not straight lines in between those. But we've managed to sketch the curve there.